Hi, this is the missing part of my talk at Java On, where I ran out of time because it turns out it takes a lot longer to get 20 responses on Mentimeter than it takes to get a live audience to raise their hands 20 times. Who could have known, right? Anyway, we just looked at two reasons why you might have too many chunks in a chunk, which overwhelm the working memory of the reader. So this could lead you to think that if you just limit the number of chunks in a chunk, then you're fine and the reader will be happy. But actually, if you do that, then you might end up with something like clean code gone wrong. So here, meet Josh. Josh is a super smart career changer who only attended a 4-month boot camp, but he's making up for that with diligence. He didn't have the time to read Clean Code, the book, but he did read an article with the most important clean code rules, and he is taking them very seriously. Josh extracts every Boolean condition into a method with a meaningful name, even if it was already perfectly readable. He gives every class an interface, even if it's only used from within the same package and there's only one implementation. Every method is made shorter by extracting more methods, even if those methods in the end don't do anything interesting. Every literal is extracted into a named constant, even when the meaning is completely obvious. Or, even my ultimate favorite, yeah, I have seen that multiple times. But what happens when you're reading Josh's code? You have to click down into all of these methods, and the only way to keep track of where you are and where you came from is to keep a mental record of the steps that you have taken. And as you're doing that, what is it that you fill up? Your working memory. Once you finally get to the place which holds the implementation, then you have to choose between understanding it or remembering where you came from. In this situation, we have not enough chunks in a chunk, which is over abstraction, and it leads to the same issue. You don't have a well-chunked structure. The reader's working memory is overwhelmed. So it's not enough to add enough abstraction, since each layer of abstraction comes at a cost, the indirection. Now, indirection is the phenomenon where you look for a thing, and instead of the thing, you just find a note telling you to find the thing somewhere else. If your indirection is just a function in the same file, then you control-click, you jump there, you can jump right back, no problem. Maybe you have a function in another file. So you control-click, it opens in a new tab. It's usually fine, but maybe you get a phone call or your colleague taps you on the shoulder, and once you get back to that new tab, you don't remember why you're there anymore. You figure it out, but it takes time. And then this escalates and escalates until you have things like generated code, where you have to build the project to see the code that actually runs, or even dynamic dispatch, where you have no idea what implementation is used unless you run and debug into the code or investigate the logs and look at those messages. A lot of indirection results in a structure where you need to dig and dig and dig until you find what you want. Therefore, abstraction can increase cognitive load, not just decrease it. Let's look at the fundamental theorem of software engineering, which explains this perfectly. All problems in computer science can be solved by another level of indirection, except for the problem of too many levels of indirection, by David Wheeler. John Carmack has a perfect response with the solution, which is inlining. That does have advantages. You should be made constantly aware of the full horror of what you are doing. Well, of course, full horror is a bit too much, but Josh's examples that we saw before could definitely use some inlining. I would call these useless indirections. And Josh was doing them because he was misinformed about clean code, but maybe you are doing them for a different reason. Maybe you are trying to make space for a possible future feature by creating something reusable right now, even if you don't need it right now. Yagni. Or maybe you're abstracting out of habit, like we saw with the one interface for everything. Or maybe you're exercising your chops. Maybe you just came out of design pattern class and everything looks like a strategy. So you make everything a strategy, even though it could be something much simpler. I know I've done that in the past. I try not to do that now. If you like this stuff and you would like an infinite resource of useless indirections like this, check out FizzBuzz Enterprise Edition. It's a lot of fun. So let's conclude by saying that before we abstract, we should ask what we gain. Do we hide complexity, explain intent, reduce coupling, or eliminate duplication? So those are all good reasons to abstract. That should be weighed against the cost of indirection that we just saw. To sum everything up, let's avoid both under-abstraction, which you saw in the previous video, and over-abstraction that you saw here, and aim for a healthy balance, where each layer of abstraction has a good amount of detail that can fit comfortably into most brains, which I like to call well-chunked. So that's it. You are ready to jump back to the previous video. I put a link down below. Just click that and you'll be right where you came from. Bye-bye.